Hi, welcome. This is Regina. In this video, I want to discuss the definition of a chemical reaction and how we are going to express a chemical reaction in a chemical equation and what balancing chemical equation is all about. Before you watch this video, you must watch my other videos on balancing chemical equations and also on ionic compounds and covalent compounds. It'll come in handy. So what is a chemical reaction? A chemical reaction is when the atoms of the original material, called reactants, rearrange to form the products. Consider this fictitious example here. Let's say a compound or a molecule was made up of atom A and B, and another compound or molecule was made up of atoms C and D. The left side is called the reactants. So these two compounds here are reactants, and the arrow would tell us that is gone to produce the products. So what really happens is that the bonding between A and B breaks, and the bonding between C and D breaks. C and D, the bonding between C and D breaks, and new bonds are being formed. A is forming a new bond with D, and B is forming a new bond with C. So notice that no new atoms are created. The same atoms are simply rearranged to give you the products. So that is the basic understanding of what a chemical reaction is, or rather how a chemical reaction is depicted. Now, how do we know that a chemical reaction has even occurred? You want to look for signs like formation of gas, change in color, formation of precipitate if the test tube has gone cloudy. These are indications that brand new compound has been formed and that there must be a chemical reaction. Now, one more thing. I want you to get very familiar with lowercase g parentheses, and these are always as a subscript, L parentheses and S parentheses, and we will use this when we learn to balance chemical equation. G for gas, L for liquid, S for solid. We must indicate whether the compound is in the gaseous form, solid form, or the liquid form. One more. There is something called AQ. That's called aqueous. And if a compound is soluble in water, such as salt, we might want to write NaCl, which is sodium chloride, aqueous. That tells us that if sodium chloride is put in water, it's going to dissolve. I want to look at this problem that we see here. The following are molecular views of two different possible mechanisms by which an automobile airbag might function. One of these mechanisms involves a chemical reaction and the other does not. By looking at the molecular views, can you tell which mechanism operates via chemical reaction? Well, look at this. There are atoms here which are attached to these atoms. There are a group of 3 atoms attached to gray atoms. And after something happened to the reactant, let's put down reactant here. I feel like we've produced brand new compound. We don't see this on this side, although if we counted the atoms 1, 2, 3, 4, 5, 6, 7, 8, I'm hoping to find 8 on this side. 1, 2, 3, 4, 5, 6, 7, 8. And the black dots, instead of being in triplet, it's double, probably some diatomic compound. And the number should match on both sides. So there's 1, 2, 3, 4, 5, 6, 7, 8. 8 threes are 24, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So you can see that the number of atoms on either side, they match perfectly. But what you started with is completely different from what you end with. All right, so this is a chemical reaction. For this one here, what you started with is the same as what you end up with. You have diatomics here, which are blue, and some red diatomics. You have 3 red diatomics, 3 red diatomics, and I'm assuming the equal number of blue diatomics. You can pause the video and count it. So let's move on to answering some questions here. Which observation is consistent with chemical reaction occurring and why? The first one, solid copper deposits on a piece of aluminum foil when the foil is placed in blue copper nitrate solution. The blue copper of the solution fades. Okay, well, this is a chemical reaction because you didn't start out with any solid copper. You started out with copper nitrate. So if you remember from my naming video, copper, I'm going to assume it's 2 plus. From my 2132 rule, you will determine that the nitrate is 1 minus, and copper nitrate is CuNO3 twice. You start out with this kind of copper in here, in an ionic form, but you're told that solid copper deposits. So somewhere along the line something happened and you ended up with solid copper. So for this one, if copper nitrate is soluble in water, you will write down AQ. If you are told that copper is solid, and I think you know that, it's solid, you will write down S. So this is definitely a chemical reaction. Liquid ethyl alcohol turns into solid when placed in low freezer temperature. Well, do you think that ethyl alcohol turned into something else just because it's solidified? B is definitely not a chemical reaction. You simply froze it. It's kind of like saying ice is not water anymore. A white precipitate forms when solution of barium nitrate and sodium sulfate are mixed. So when barium, you start out with barium nitrate and barium sulfate. You are told that these are solutions. So if there are solutions, then most likely both are soluble in water. You created something that is not soluble in water. Formation of a precipitate is a classic example of a chemical reaction. A mixture of sugar and water bubbles when yeast are added. Where did the bubbles come from? After several days, the sugar is gone. Ethyl alcohol is found in water. Well, the atoms that made up sugar got rearranged into ethyl alcohol. And the bubbling could be carbon dioxide. We don't really need to know that, but we do need to know or recognize that we started out with sugar and water. It bubbled when yeasts were added, and then when you went back, there was no sugar. So this is indeed a chemical reaction. Vinegar forms bubbles when it is poured onto calcium deposits on a faucet, and some of the calcium dissolves. Has a chemical reaction occurred? Explain your answer. Well, at this point, I'd like you to pause the video and think about an answer, and then we'll go over it. Okay, formation of gas, which is what I think bubbles is. If vinegar is forming bubbles, a gas has been produced. So I would say this is a chemical reaction. When commercial hair bleaching mixture is applied to brown hair and hair turns blonde, has a chemical reaction occurred? Well, yes, it has, because you cannot go back to the original brown hair color. So definitely a chemical reaction has occurred to cause the change in the hair color. Okay, Before I actually get into balancing chemical equation, I want us to look at this. List the number of each type of atom on both sides of the equation. Are the equations balanced? So that, as I said before, the number of atoms you start out with must match the number of atoms you end up with. I have altogether 4 atoms of silver. And indeed, I have 4 atoms of silver on this side. I have 2 atoms of oxygen. And I have 2 atoms of oxygen. If it's difficult for you to see that there are 2 atoms of oxygen, make silver oxide. Just go 2 silver atoms and 1 oxygen atom, and that is silver oxide here. And if there's 2 of these, as we're told, there's another silver stuck somewhere in between there, and it's ionic compound, so I would imagine the cations and the anions are actually held by opposite charges attracting each other. So look, there are 2 oxygen atoms. We usually write it this way, and it is understood that this 2 means oxygen, and you do have 2 oxygen here. You only have 1 carbon on the reactant side and 1 carbon on the product side, so the first one is indeed balanced. Okay, for this one here, you have 2 nitrogen and 6 oxygen and only 1 lead. You can draw a picture for yourself and prove it. So you have lead and you have nitrogen with 1, 2, 3 oxygen stuck together to make a polyatomic anion, and there's another nitrogen with 1, 2, 3 oxygen stuck together to make another polyatomic anion. This whole polyatomic anion is nitrate, negatively charged, nitrate, negatively charged. I would imagine this would have been positively charged, and they're all stuck together and neutralized. So you can see 1, 2, 3, 4, 5, 6 oxygen, 1, 2 nitrogen, and only 1 lead. This is how we write it. Okay, let's count lead, 1 each. Let's count nitrogen, 2, and we have 2. Oxygen, 6. 3 times 2 is 6. 2 sodiums, 2 sodiums, 2 chlorines, and 2 chlorine here. I always recommend that you draw a picture. I will just do one more here. This is sodium, and stuck together is a nitrate polyatomic anion, just like this. And that's 1 sodium nitrate, and there's another one, and there is a nitrate, 1, 2, 3 oxygen makes a nitrate, and they both have 1 plus 1 minus charge, and they're both, there's only 1 nitrate for 1 sodium. That's what 2 sodium nitrate is. So count the oxygen, 1, 2, 3, 4, 5, 6, which is the same as here. Count the nitrogen, 1, 2, and 1, 2. Lead is 1. Lead chloride would look something like P, B, Cl, and there's 2 Cl's here, and there are 2 chlorines here and 2 chlorines here. But let's try doing this without drawing. 3 carbon, 3 carbon. 8 hydrogen, 4 times 2, 8 hydrogen. 2 oxygen, 3 times 2 is 6, plus 4, 10 oxygen. This equation is definitely not balanced. Okay, so this is how you identify whether an equation is balanced or not balanced. So last one is not balanced. You can pause the video and convince yourself that the last one is not balanced. Okay, I now would like to go through balancing chemical equation. The first one, Solid lead 2 sulfide. Lead is 2 plus. Ends in an "ide." Look up your periodic table. Symbol is S and it's a 2 minus group. It reacts with hydrochloric acid. Well, let's make this first. So this gives me, for every one lead cation, and I will only need one sulfide because they're both 2 minus 1 each, we'll simply neutralize it. Ic acid, and it starts out with a hydro. So look up chlorine in your periodic table, and it has a 1 minus charge. Take the charge out and add an equal number of hydrogen in the front, and this is what hydrochloric acid is. Lead chloride. You have Pb2 plus Cl1 minus, and that gives you PbCl2. Okay, and dihydrogen sulfide, that's covalent, a very different system, dihydrogen sulfide. So that's what we first have to do. Look at all the reactants, look at all the products, and turn them into formulas based on what you've learned in all 3 of my naming videos. This is naming ionic compound, in the naming ionic compound, and this is naming the acid, and this is naming covalent compounds. Okay, let's go ahead and create an equation here. So lead sulfide is PbS plus, and it's told solid, so we have to say solid here. HCl is aqueous, so we're going to have to say aqueous. And it produces lead chloride. Doesn't say what form. So PbCl2, and the other one is gas, dihydrogen sulfides. Okay, so I have here lead sulfide plus aqueous hydrochloric acid gives me lead chloride and hydrogen sulfide gas. I need to balance this. I have 1 lead here and 1 lead here. I have only 1 chlorine here and 2 chlorines here. So I'm going to try and put 2 here to make it 2 chlorines. In putting 2 chlorines here, I ended up getting 2 hydrogens here. So I have to go back on this side and check to see if I have 2 hydrogens. Indeed, I have 2 hydrogens. I have 1 sulfur and have 1 sulfur. I've checked every single atom and they're balanced. So this is my balanced chemical equation. Okay, pause the gaseous carbon monoxide reacts with hydrogen gas to form gaseous methane and liquid water. Let's go ahead and count. This should be in parentheses. 1 carbon, 1 carbon. We're good so far. Oxygen 1, oxygen 1. It's looking good. I have altogether 6 hydrogen here. 4 plus 2 is 6, and I've only got 2. I have to put a 3 here so that it's balanced. Solid iron 3 oxide ion is 3 plus. Oxygen is 2 minus. Crisscross gives me Fe2O3, which is how I got Fe2O3. If you're told it's solid, you have to put it down. Reacts with hydrogen gas to form solid iron and liquid water. There's only 1 Fe on the product side and 2 here. So let's go ahead and try putting 2 here so that the iron is balanced. We have 2 hydrogen and 2 hydrogen, but look at oxygen. It's 3 here. So the only way we can balance the oxygen is probably to put a 3 right over here. That gives me 3 oxygen. But at the same time, if I put 3 molecules of water here, I also ended up getting 6 atoms of hydrogen that came from 3 molecules of water. So I will have to put more hydrogen molecules on this side so that all of the atoms are balanced. The last one, gaseous ammonia reacts with gaseous oxygen to form nitrogen monoxide in gaseous form and gaseous water. It's steam. It's probably very hot. All right, so let's look at nitrogen, which is balanced. Let's look at hydrogen, not balanced. There's 3 here and 2 here. So I want to try move this aside a little bit, see if I can find some room here. I want to try and get 6 hydrogen and put 2 here so that the hydrogen is balanced. That means nitrogen is 2 here. I have to put 2 here to balance the nitrogen. That means I have altogether 3, 4, 5 oxygen. On this side, I cannot put a number here which can be multiplied by 2 to give me 5. So let's get a little clever and say 5 over 2, because 5 over 2 multiplied by 2 over 1 does give you 5. But you also know that in chemistry you can't have a fraction. So you can basically get rid of your fraction by simply multiplying every single number here by 2. So you end up with 4 ammonia gas. Here's the final product. 4 ammonia, 5 moles of oxygen, 4 moles of nitrogen monoxide, and 6 moles of water. And that equation is now balanced. I'd like you to pause the video and try this on your own. First one is magnesium solid plus copper nitrate. It's copper 1. Nitrate, you will know, is NO3 1 minus. So it's copper nitrate, forming magnesium nitrate, aqueous, and solid copper. Let's balance this. 1 magnesium here, 1 magnesium here. What I want you to notice is the anion nitrate, it remains intact in this particular reaction. Nitrate stays as nitrate. The only thing you see is that the nitrate in the product is doubled. So if you want to bring another nitrate here, just bring in another copper nitrate. So you have 2 nitrates. And because you brought 2 here, simply add a 2 in front of copper and the copper is balanced. So everything is all balanced now. Okay, let's move on to the next one. Gaseous dinitrogen pentaoxide. Dinitrogen pentaoxide, it decomposes to form nitrogen dioxide and oxygen. You have 2 nitrogen here and only 1. So we can start out by trying to balance the nitrogen. And then we have altogether 4, 5, 6 oxygen, and you only have 5 here. So we need to do some work here. Let's keep trying. So the 2 nitrogen is not going to work. We remove the 2 and try another number here. So let's go ahead and see what's happening with the oxygen here. You have 4 here and you have 5 here. Okay, my second strategy would be to double this. So what would happen if I doubled it? If I doubled this, I will end up with 4 here because I need to balance my nitrogen, And at the same time, I realize that I have 10 oxygen. 4 times 2 is 8, plus 2 is 10. Well, I was a little lucky here because the first guess worked. Sometimes you have to keep going back and forth until you find numbers that you can put in front of each of these balancing chemical equations. Calcium reacts with aqueous nitric acid to form calcium nitrate and hydrogen gas. Again, I noticed that the nitrates have not broken up. So it's very easy. There's 2 nitrates in the product. I'm going to start out with balancing the nitrate as a complete anion unit. That makes this hydrogen twice, and I have 2 hydrogen here already. Calcium's 1. So that worked out. Now let's go on to the next one. Now CH3OH will react with oxygen to produce carbon dioxide and water. Oaks that are not all over the place. Here, there's oxygen here and oxygen here. So I'm going to try carbon, which is already balanced, 1 each. I have 4 hydrogen here, and I only have 2 here. So I will make 4 hydrogen by putting 2 water on this side, looking to see what happens to oxygen. 2 plus 2 is 4 oxygen. I already have 1 here, so I need 3 oxygen here. So again, we will use our fraction trick. 3 halves times 2 will give me 3. So altogether, I do have 4 oxygen here and 2 4 oxygen. Double check hydrogens, 4. 3 plus 1 is 4. Carbon is still 1. And it looks good. Once you're happy with it, then all you have to do is multiply by 2 to remove this denominator. Let's go ahead and check to see if it's still balanced. 2 carbon, 2 carbon. 3 plus 1, 4 times 2. 4 2s are 8 hydrogen. 4 times 2 is 8 hydrogen. 3 2s are 6, 7, 8 oxygen. 4, and there's 4 oxygen here. 4 plus 4 is 8 oxygen. So we'll read this problem. Hydrogen gas has been widely proposed as a potential fuel to replace fossil fuels. Some scientists are trying to anticipate any potential problems that might be associated with a hydrogen-based economy. One group of scientists has calculated that the amount of atmospheric hydrogen could increase by a factor of 4 due to leaks in hydrogen transport and storage. Upper atmospheric hydrogen gas reacts with oxygen gas to form liquid water. This is the first chemical reaction. Hydrogen gas reacts with oxygen gas to form liquid water. So this, I already balanced this for you. You can see that there are 2 oxygen here, so I put a 2 here, making hydrogen 4, and by simply putting a 2 here, the hydrogen's 4 as well. So this whole equation is balanced. An increase in upper atmospheric water would enhance the processes that release atmospheric chlorine atoms. Typically, we don't have chlorine atoms in a chemical reaction unless they actually say it's an atom. So I would only write Cl rather than Cl2. The gaseous chlorine atoms would then react with gaseous ozone to form gaseous chlorine monoxide, ClO, and gaseous oxygen, O2. And to balance this, I have 1 chlorine, 3 oxygen. This is already balanced. Moving on. Okay. I have 4 questions here. Let's pause the video and try this on our own first. When solid sodium is added to liquid water, it reacts with water to produce hydrogen gas. Solid sodium reacts with liquid water to produce hydrogen gas and sodium hydroxide. Write a balanced chemical equation for this reaction. I have 1 sodium here. I have 3 hydrogen here and only 2 here. If I put another 2 here, I end up with 4 hydrogen, which allows me to make a 4 here. Because of this 2, I know that I have to work with even numbers. That gives me 2 oxygen, and I already have 2 oxygen. That also gives me 2 sodium, so I'll need to put 2 here so that the sodium's balanced. Pause the video and try the next one. Sulfuric acid in acid rain forms. So sulfuric acid is here and it is a product. When sulfur dioxide, a pollutant, reacts with gaseous oxygen and liquid water. So sulfur dioxide plus oxygen plus water gives you sulfuric acid. Let's count the atoms. The sulfur is fine. Let's look at oxygen. Here's 2, 4, 5, and there's 4. It's always best to make oxygen in even numbers. So my first guess would be to double this. That's the first thing I can do. So I have 8 oxygen here. Be careful, when I doubled this, I also have to take care of the sulfur by putting a 2 here. And I also need to put a 2 over here and then see what happens. So I have altogether 8 oxygen and 2 sulfur. Sulfur is fine still. Oxygen is 4, 5, 6, 7, 8. Hydrogen is 4 and hydrogen is 4. So that worked out. Write a balanced chemical equation for the reaction of solid vanadium 5 oxide. Vanadium has a 5 plus and oxide has a 2 minus. So vanadium 5 oxide would be V2O5 reacting with hydrogen gas to form solid vanadium 3 oxide. Vanadium is 3 plus, oxygen 2 minus. So vanadium 3 oxide would be V2O3 and liquid water. So let's see, vanadium, there's 2 here. I have 5 oxygen here and I only have 4 here. How about if I put a 2 right here? Then 3 plus 2 gives me 5 oxygen. That makes my hydrogen 4, and I can fix that by putting a 2 right here, and we have it all balanced. Write a balanced chemical equation for the fermentation of sugar C12H22O11 by yeasts, in which aqueous sugar reacts with water to form aqueous ethyl alcohol C2H5OH and carbon dioxide. So here's sugar plus water gives you ethyl alcohol and carbon dioxide. So we can proceed to balance this, going back and forth until all of the atoms are balanced. I think this question is a little difficult. I have 12 carbon here, and I want to remove my initial thought of 5 carbon and my initial thought of 2 carbon. So I have 12 carbon here, and this may not be as difficult as we think it is. I have 2 carbon here and 1 carbon here, and what if I put a 4 here that gives me 8, and 8 plus what gives me 12? 8 plus 4 gives me 12. So I will try 4. So 4 times 2 is 8, 9, 10, 11, 12. So I have 12 here. I have 24 hydrogen altogether and 12 oxygen altogether. I have 5 plus 1, 6, 6 4s are 24. My hydrogen's already balanced. I have 12 oxygen here, and I have 4. 4 times 2 is 8. 8 plus 4 is 12 oxygen. So I'm balanced. I now want you to pause the video again and try and balance this equation, and I will come back and go over this. These questions are a little easier because they've already worked out the formulas for you. So let's see. We have 2 sodium here Let's try putting 2 here. I have 2 nitrates here and I have 2 nitrates here, so that's good. I have 1 sulfur here and 1 sulfur here, 1 copper and 1 copper, and it's balanced. HCl plus oxygen gives me water and chlorine. I have 2 chlorine atoms here, so I have to put 2 here, which makes a hydrogen 2, and it's already 2 on this side. I have 2 oxygen here and only 1 oxygen here. So that means I will have to put 2 here to balance this oxygen. By virtue of putting a 2 here, I ended up having to put a 4 here. So be ready to change your mind, erase this out, and replace it with a 4. Now that makes chlorine 4. And you just simply put 2 here and you're all good. Hydrogen plus oxygen gives you water. I have 2 hydrogens. There's 2 oxygen here and only 1 here. So again, I'll have to put 2 here so that the oxygen is balanced. And then the hydrogen has to be balanced by putting a 2 here. Iron sulfide and hydrochloric acid gives me iron chloride and dihydrogen sulfide. I have 1 iron, 1 sulfur, hydrogen I have 1 and there's 2, so that's not balanced. Neither is chlorine. So let me try putting 2 here. That balances the chlorine and it actually also balances the hydrogen. So now this is a balanced chemical equation. The first one, barium oxide, BaO2, reacting with sulfuric acid, aqueous, which basically means it's soluble in water, produces barium sulfate solid, so this would have been your precipitate, and H2O2 aqueous. This is hydrogen peroxide, and aqueous again means it's dissolving in water pretty nicely. Let's go ahead and look at sulfate, a polyatomic ion which remained intact. This time they're both balanced. So we have 2 hydrogens here and 2 oxygen here and 1 barium here. So this reaction is balanced as is. I have 3 nitrates here and I only have 1 nitrate here, so I will put 3 right here. This whole equation reads cobalt nitrate aqueous, meaning cobalt nitrate is soluble, ammonium sulfide aqueous. Ammonium sulfide is soluble in water. It produces a precipitate, cobalt sulfide, and ammonium nitrate, which is aqueous, so it's soluble in water. So let's go ahead and balance the nitrate, which makes ammonium 3. And ammonium is 2 here, so we already know it's not going to work out. So we will have to work on this. And let's work on this together. So I'm going to go ahead and remove my initial thought of 3 and think again. Well, I just noticed 2 cobalt here. So why don't I put 2 in front of cobalt? See if I can squeeze in a 2 right over here. So then that gives me 6 nitrates. So what happens if I put 6 here to balance the nitrate? I'm going to have to put 3 over here to make the ammonium 6. Keep the polyatomic ions together when balancing the equation as much as possible. That gives me 3 sulfur and it already is 3. So I think we're all balanced. It's a lot faster and easier if you see that the polyatomic anions or cations, in case of ammonium, has not broken apart. Keep them together and treat them as a single entity. The next one, lithium oxide. This is not dilithium oxide, by the way, because it's ionic. The 2 came because of the 2 minus here. Water gives you lithium hydroxide. There's 2 lithium here. Let's go ahead and balance the lithium right away. That gives me 2 oxygen and I have 2 oxygen. That gives me 2 hydrogen and I have 2 hydrogen. Mercury acetate. 2 acetates here. I see that the acetate has not broken, so the entire group of acetate, I will try and balance them together. So I will do that by putting a 2 right in front of potassium acetate. That means potassium becomes 2. So I go back here and balance the potassium. That means chloride is 2. Already have 2. Mercury is already 2. So it's all balanced. Next one is already balanced, and we have to determine whether each chemical equation is correctly balanced. If not, then correct it. I have 1 rubidium here and 1 rubidium here, 2 hydrogen, I have 3 hydrogen here, so this is not correctly balanced. So we will have to balance this. Rubidium, if we put 2 in front of rubidium, that gives me 2 oxygen, and that by putting 2 in front of water gives me 2 oxygen. That's 4 hydrogen here, and 2 plus 2 is 4 hydrogen. So we're balanced here. Let's look at this one. 4 plus 2, 6 nitrogen, 6 nitrogen here, 4 2s are 8 hydrogen, 4 2s are 8 hydrogen, 4 oxygen, 4 oxygen. This is balanced, so we're good there. I have 1 nickel on both sides. I have 1 sulfur on both sides, and 2 oxygen here and 3 oxygen here. So that's not balanced. We'll have to balance this one. Okay, we have an odd number of oxygen here. I'm thinking if I put 2 here, I will have to put 2 here to balance the nickel, and then I will have to put 2 here to balance the sulfur. The only way I can tell is by doing it. So let me try out a 2 here. That gives me an even number of oxygen at least. But I do have to balance the nickel on this side. Then I have to go balance the sulfur. And then I want to check how many oxygen atoms I've created. 2 times 2 is 4, 5, 6. So all I have to do is put a 3 here. Balancing equation is actually practice makes perfect. So let's look at this last one here. Lead oxide plus ammonia gives you lead, nitrogen, and water. I have 1 lead. I have 1 oxygen and 1 oxygen. I have 2 nitrogen, and I have 2 nitrogen, and I have 6 hydrogen, and I only have 2 hydrogen here. So that's not balanced. We need to balance that. Okay, so first I noticed that there's 2 nitrogen here. So I want to put 2 here to balance nitrogen. That gives me 6 hydrogen. I have to go back on the other side and put a 3 here to get my 6 hydrogen. That gives me 3 oxygen. I have to go back here and put a 3 here to balance the oxygen. That gives me 3 lead. I have to go back here and put 3 right over here. This is my last slide. Human cells obtain energy from a reaction called cellular respiration. Balance the skeletal equation of the cellular respiration. So here's the balanced equation. C6H12O6, which is glucose, plus oxygen gives you carbon dioxide and water. So you have 6 carbon. So you can try putting 6 in front of carbon. That gives you 12 oxygen. Because you see oxygen in 2 different places, hold the thought on oxygen for a little bit. Try the hydrogen first. You have 12 hydrogen. So by putting 6 in front of the water, you'll get 12 hydrogen. Now do the oxygen count. So you have 12 plus 6, you have 18 oxygen. You already have 6 here. So if you put 6 here, 6 2s are 12, plus another 6 will give you 18. Catalytic converters work to remove nitrogen oxides and carbon monoxide from exhaust. Balance the skeletal equation for one of the reactants that occurs in a catalytic converter. So we have 2 nitrogen here. So how about putting 2 here? So nitrogen's balanced. Well, I have oxygen here and here. Let me see if carbon is also balanced. So it's time for me to look at oxygen seriously. I have 2 oxygen here. I have 3 oxygen here. If I put 2 here to make oxygen even so that I can balance it, I have 4 oxygen here. And I will be forced to put 2 here to balance the carbon. and oxygen is also balanced. There's 4 oxygen here, 2 plus 2 is 4. Check your nitrogen, 2 and 2. Check your carbon. We're all balanced. Thank you very much for listening to this video. I'll see you again. Goodbye.